So today's session is going to be about the TJ bot, and you might have seen the TJ bot around and about. It's a beautiful cardboard box with a couple electronics in it, and then it gets very creepy after that when you can control it and do all sorts of things because you can. So let's start with what is the TJ bot. It's a Raspberry Pi powered Watson Maker Kit, and everyone go, or oh my God, I gotta leave. This is getting creepy. No, really, it's honestly just a Raspberry Pi. It's only what the developer does to it that makes it creepy. No, so let's see. There's a Raspberry Pi camera that's connected to it. We got a servo on the left side and an LED on the top. And then you can connect a speaker. I have one connected via USB, and I believe I have a microphone here underneath. And so it can capture audio, so you can talk to it. It'll talk back to you. And then it can shine its light. It can wave its arm. And then it uses Watson services behind the scenes to make this more interactive. So you might go, oh, so this is that new IBM product that's going to be in every home. No. This is a maker kit that you can build, enhance into whatever you want it to be. And if you want to make it into a home product or an office product, go for it. It's all open source. We're not going to take any royalties. Well, maybe we will, but this is more of a fun maker kit. And so I want you to keep in mind that it's not something that we're going to have a platform that you train skills, you share the skills, you sell them, nothing like that. It's all open source, and hopefully when you build something that's open source with it, you'll put it on GitHub, you'll write about it on a blog, maybe an Instructable, that you will share what you've built. Because the most important thing I've learned as a developer is to build something and then explain how I built it so everyone else can share in that knowledge and further progress everyone's knowledge. All the boats rise at the same time. That should be something we all think about, and then we figure out how to monetize it with our own services or whatnot. So TJ Bot started about late last year, so we're coming up on the first anniversary of this project. It was kind of a side project from another IBMer on the East Coast, and she created it. It's Mariam Ashrawi, and she was trying to find how you would enable an object, whatever it be, with cognitive capabilities. And so she explored how you build an object, like this cardboard box, and then what capabilities you could enable it to be. And so using Watson services, you can understand natural language, you can enable it to talk, listen, and other activities. So if you want to go on this blog and really understand the reasoning behind it, I encourage you to do that. So it's really a collection of DIY tutorials that we've built to get this started. So you'll see the 6 Watson services that we chose. We have given you recipes, and they're in Python, in Node, and Node-RED. You can also write code. If you can write it on a Raspberry Pi, you could probably run it. I believe Java for Liberty can also run on the Raspberry Pi, and so maybe you could use that language as well. He was affectionately named after Thomas J. Watson, the first chairman and CEO of IBM. So it's kind of honoring our ancestry and history of IBM. So how do you build this bot? Well, you can go on Adafruit and buy a full kit, or you can buy the individual parts from Amazon or SparkFund. It depends on if you get the full package from Adafruit, it's $150. You can get it down to like $100, $120 with buying them individually on Amazon. If you buy it on Amazon, you also get more LED lights and more wires. That's always a good thing when you want to tinker with hardware. So check that out. So this video is going to show you how to build it. It comes with two slabs of cardboard, and you basically pop them out. You're folding them. The cardboard is perforated. One caution is to fold it the right way, because if you try to fold it the other way and then fold it back, it's perforated cardboard. You're going to snap it off, and then you end up taping it. If you want to see a nicely taped up and bandaged TJ bot, we have one out back we can show you. So you may see some of these getting a little beaten up. The cardboard one is a little bit more fragile. We also post the 3D printed designs, so you can 3D print your very own plastic TJ bot. That's a lot more durable, and you can tinker with either one of these designs to add a second arm or to modify the body. And so that's where the open source part comes into play. You can make it be whatever you want, and that's something cool that you can do. So the Raspberry Pi goes in the middle, and then the rest of the cardboard goes on. You got the LED that gets attached to the top with, I think there's 3 wires on each of those parts. And then you put the servo in. It's like a helicopter motor that you connect to the arm. The black box, what do you? Oh yeah, so you can also embed a square box speaker in the back of the TJ bot. So you'll see on the back of the TJ bot, there's this big opening, so you can store stuff in there. So this is a USB speaker. You can find that on Adafruit. It's, I think, like $12. This is just powered by USB using a micro USB cable, power cable. You can connect an HDMI cable to this Raspberry Pi and run the whole Raspbian desktop on it. If you've never played with the Raspberry Pi, it is a powerful computer that you can basically hack other hardware to and connect to it. So this is the wiring schematics to connect the servo and the LED. And you'll see on the bottom the HDMI port in the middle, and then the USB power on the left side of the bottom. It comes with 4 USB ports, so if you have other USB devices you want to connect to it, you could probably power the TJ bot with those things. Connectivity, Wi-Fi, and Bluetooth. So we use Wi-Fi connected to a network, and you can access it over the network. So when you get started with this, you want to enable 3 components of on the Raspberry Pi. You want to enable the camera option. It's not enabled by default. And then 2 convenience parts, SSH. It's no longer enabled, so you want to enable that so you can SSH into your Raspberry Pi. It's a Linux operating system, so you can, again, do a lot of things with that operating system. And then VNC, you can access a remote desktop and run the Raspbian desktop and I guess do word processing while having TJBot do other things if the memory allows that. All right, so we have the hardware, we have the TJBot built. The next component is the Watson services. And this is where you really can get more advanced with the TJBot. It's not just blinky light or waving the arm. You can actually enable a cognitive object. And so these are the 12 services available in the IBM Bluemix platform. 6 of them are enabled in the TJBot recipes that have been offered. If you find that one of these other 6 are really useful, contribute to the open source library, either in Node or Node-RED or Python, and we'll see if we can get that one up and running as well. But there's 6 basic services. So Conversation is a chatbot engine. So you can train Watson with intents, which are like actions or verbs, and entities, which are objects or nouns. And so when I say turn the light red, I can train Watson to say, or recognize turning light as an intent or the action, and then red to be a color. And so as you change the dynamics of the user input to say blink the light red or activate the light magenta, you can have a bunch of different variations, and you've trained Watson with this is a turn on intent and this is a color. And so then your application will take over and say, all right, this was the intent that all these other options got boiled into, and I'll recognize its turn light as an intent and the color, and then I can command the bot to turn the light whatever color. Then you have Language Translator, which is a language translation service. So if you want to make your bot multilingual, you can have it understand English, French, Spanish, Italian, and many other languages. You can also make it be able to translate from one language to another. So a recipe I wrote was basically listening as one language, recognizing which language it is, and then translating it into another language. And then I use this microphone and speaker to listen and speak out the translated content. So you may speak in Spanish to me, and I only recognize English, and we can both converse back and forth through a TJ bot. So then Tone Analyzer is the next service that is offered. This analyzes emotion, social tendencies, and language style. So you can understand the 5 emotions: anger, disgust, fear, joy, and sadness, and have the TJ bot respond. So one of the community projects that happened by a little girl, she has a conflict resolution TJ bot. And so you can tell it, someone beat me up today at school, or something with more emotion, and then it would recognize that emotion of fear or sadness, and then respond in a way that can maybe console the user or the child in a way that they can resolve the conflict on their own, or as she presented, TJ bot couldn't really resolve it, and so go talk with an adult. And so when maybe as a child you didn't have the confidence to go up to an adult and say someone's beating me up, you could feel more comfortable with the TJ bot as the method of consoling yourself and resolving it in a more personal way. We have the text-to-speech and speech-to-text service, so you can speak, or you can listen to the user's speech and then transcribe it into text. That's great when you can pass it over to conversation and get the understanding of the natural language. And then text-to-speech, you can then speak out text into both different accents and language, so it can speak Spanish, French, English, Italian, and even a British version of English. So you can make that more localized to your user. And then you can also use this synthesized syntax markup language, which is kind of like HTML, where you're marking up the text, and you can have it apologize or have different tones. So apologizing, sadness, and many other ways, even the pitch and the speed. So you can vary the synthesized voice into a more comforting voice if needed. And then lastly, visual recognition is the image-based analysis. So using the camera, it takes a photo and then uploads it to the Watson service in the cloud. It will return objects and colors with confidence scores, and then you can then say, oh, it's a teddy bear, or it's a classic monster of our childhood. And so you can recognize different things. You can use a basic public training set that we have for Watson, or you can classify your own objects by uploading example images of each object you want to recognize, or each classifier. You can find more info at the TJBot GitHub account. So I'm going to just dive into how you can use Node-RED as one of the options. So Node-RED is a graphical interface, and I can show you this. On the right side, it's a web-based editor, and it's built on top of Node.js. And on the left side are these nodes in the palette that you can drag over to the canvas, connect them together, and build a quick prototype. It was developed about 4 years ago for IoT devices, and you can use it for IoT or any project you want. And we find this is a great way to quickly prototype an idea. You don't have to write too much code. You can write JavaScript functions in the editor if you want that kind of code level access. It's an open source project. It's part of the JS Foundation, and it's community driven. So you can find a lot of nodes that have been written by the community, and you can even contribute your own. If you've met an API here at CodeCamp or some service that doesn't have a Node-RED node, this is great where you can write your own custom nodes for the Node-RED community. You can find more info at nodered.org, and then flows.nodered.org is the site where you can find nodes and also more evolved examples of flows. All right. So I spent my August every day writing a different example of how you can train TJBot in Node-RED. If you're interested, you can find me on Medium and .com/@JeanCarl Bisson. It was an interesting month of spending a month with the TJBot and playing around with all the different things you can combine. And so I have a video of each of the tutorials. I walk you through the flow and the kind of the thinking of why I created each of these things. I'll dive into that in a second with more examples. So to access Node-RED running on the Raspberry Pi, you can access it over the network. So connect both your laptop and the Raspberry Pi together on the network. Make sure the network kind of lets you access devices over the network. Some public networks don't let that device-to-device communication happen, and so I use a hotspot as a way to make this all portable as I speak at many conferences and meetups. So I wrote these TJBot nodes over the summer because I saw the node version of the TJBot library, and I said, great, that's code recipes are great, but I'm really a fan of Node-RED. I've been writing tutorials and all sorts of things with Node-RED, and I build stuff very quickly using Node-RED because I need to get some stuff out quickly, but also I don't know if it's actually a good idea until I'm playing around with it. And then being able to evolve the project into a bigger and bigger project. Node-RED lets me keep prototyping and building out more evolved solutions. So you'll see the corresponding Watson services and which hardware that each node uses. And it's very simple to create a TJBot configuration. You can specify whether it speaks, what hardware you have enabled. So sometimes you may not have a microphone or speaker or camera, so you can disable it and have the TJBot check before you call the wave function that it actually has an arm or a microphone. So one example I have is an emotional LED. And this is kind of going back to that childhood experience of maybe getting bullied and understanding the emotion. So I have this quick video of showing how I built it. So this is a blank Node-RED interface, and I create a couple of inject nodes to activate a microphone. And I go into Bluemix, get a speech-to-text service, get the credentials, put them into the configuration option, and then I get a tone analyzer service, get those credentials from Bluemix, put those into the configuration. I can select if I want emotion or social tendencies or language style to be returned. Then I do a simple switch statement on the 5 emotions, and then I have 5 LED colors. So each one is correlated with green could be disgust, red could be fear, magenta could be anger, etc. And so that can take 5-10 minutes to construct that. In reality, it probably took me half an hour to figure out how I wanted to correlate the colors with the emotions, and then going through that creating the flow. So that's the overall flow. That's what's making that listen, analyze emotion, and then change the LED, one of the 5 colors. Cool. All right, so I'm going to switch over to Node-RED running on the Raspberry Pi. Again, this is going over a Wi-Fi hotspot, so it might be a little bit slow, but we can work through that. So again, on the left side, you have the nodes, and if I scroll down, you can see the TJBot nodes I've installed. I have a bunch of different examples. I did that yesterday, too. All right, let's see. Good. So on the left side, you have the nodes for the TJBot. So you can just drag over, double-click to configure it. Again, here are all my credentials for the different Watson services. And then you can choose what language you want to speak. So Portuguese, and Japanese are also supported, in German. So. So for the speak option, when you select one of these languages, does it change for the other one? No. So it's the text-to-speech service and the text-to-speech and speech-to-text services. Both are individual and separate. So when you say, I want to speak in German, you can also listen in Spanish. Those are separate components. Cool. So simple things, I can have it wave. So I'll click on this little tab on the left side, and it's going to wave. Uh-oh. Little buddy's arm is getting a little... All right, there you go. Arm. Let's do some exercises. Arm back, lower, and raise. So you can have it do different postures. We can switch over to the LED, and we'll blink the red light, and it turns on. So this one was an interesting one of, all right, so how do you actually blink a light? And if you think about it more electronically, you power it, and it turns on, and you turn it off, or unpower it, and it turns off. So this delay node here is just delaying that part of the flow by a second. And so it turns on, delays, and then it turns off black. We can also pulse a random color. So blue. I think that's blue. Green. It's random. All right. So you can pulse different colors. We can translate content. So let's see. Which one is this? We're going to translate from English to Spanish. And let's see. So hello from TJBot. The connectivity over the hotspot's slow. All right, well, let's see if that comes back. You can also pass in Spanish, and you can identify the language. So there's like 6 languages that the the language translator service can recognize. And then you can say, oh, that sounds, I don't know, pick a random oddball language that isn't common, that you can return that language code and then figure out how you can translate that. If it's not supported by Watson, you can probably find another translation model. And then, let's see, this one. This is wave your arm in French and Italian. Again, I only know English, but thanks to Watson, I know, 6, 8 languages. So that's, you can recognize different languages and have them translated, and then recognize, hey, you want to wave the arm, etc. So for Tone Analyzer, you can recognize the motion, language style, and social tendencies. So how agreeable, open, extroverted are you? Many other traits come in the social tendencies as well. For conversation, I have, let's see, this one's turning light. So I basically check which intent comes back from the conversation service. And so it understands turning light, a certain color, waving, and then moving a certain position. And then in the wave node, you can have it do 4 different positions, or 3 different positions, and the full motion of all 3. We got weather. So we acquired the weather company API, and so you can have 2.2 million locations of weather by either providing a GPS coordinate or a zip code or like a state and a city. And so you can have TJBot say, good morning, JeanCarl. It's going to be sunny and 72 today. Or like over the winter when I never brought an umbrella, it's going to rain, so you should bring an umbrella. Simple things like that can really improve the user experience. And then listening is another option. So the listen node has different modes. You can start and stop listening. If it's active, it's going to just keep piping audio or the transcription to the next node. When you press stop, it'll stop recording and transcribing it. For speaking, we have a speak node, or you can play an audio file. So during one of my days in August, I found the sound effects folder on the Raspberry Pi. So I had it coughing, I had it laughing, I think there's a baby crying even. So if you want to get really annoying with the DJ bot, there's a sound effects folder in the Raspberry Pi. Oh, you really want me to show you that video? Okay. So let's start with the text-to-speech. So I'll pipe in the hello. And come on, TJ bot. I think it's my hotspot. It's all about cloud connectivity. All right. Maybe I can show a video instead. And then visual recognition is the last one I'll go into. This can analyze colors, it can analyze text, it can analyze objects. So you can custom train the objects that you want to classify as well. A lot of different things that are available. As a side note, one of my projects I did was a photo booth. And so I command the TJ bot to take a photo, and it uploads to an object storage. And so you can see this will send all the pictures up to the cloud, to the IBM Bluemix object storage service. And so there's other nodes that you can interface with as well than just the Watson services. All right, so let me go over to my GitHub. So I'm on GitHub at github.com/JeanCarl. I have many different projects I've been working on. I found my passion of building prototypes and just understanding how APIs work. Let me switch over to the conference Wi-Fi. That might be better. And so when I go home at night after a long day at a conference, I'm inspired by all of you saying, oh, well, you could turn the light this color and do something. And that inspires me to say, can that happen? And how would that happen? So I guess I write code before I think about the architecture behind how applications work. But as a developer, that's what's really cool about knowing how to write code and testing out your ideas. So I encourage you to play around with stuff, even go to hackathons on the weekends and test out your skills, learn new things, and always improve your skill sets. So on my GitHub, I have a TJBot Node-RED skills, and so you'll see many, many, many days worth of tutorials. So the first day I show how you can set up the TJBot. There's a couple of things you need to flash the Raspbian OS onto the micro SD card. You need to enable the SSH VNC camera. You install the Node-RED nodes for TJBot, and then you're up and running with Node-RED. And then simple things is waving, shining the color, the LED color red. You can pulse, you can listen, you can speak, you can see objects in colors, you can analyze a tone, you can translate, you can use Watson conversation, you can listen, you can analyze emotion, and light up LEDs all at the same time. You can identify languages, you can identify language, check if there's a translation model, and then translate the content. This one was a fun one. Let me dive into the YouTube video. Do I have...
In this video, we'll train TJBot to spell out the letters and words with Watson text.
And turn on the mic.
Run the flow by clicking return from the Watson service.
Pause. Okay, so what this is going to do is take a word or a phrase, and it's going to pass it into the text-to-speech service. And what I've done is basically mark up the, let's see if I can go back to the template node. That's not readable.
Provide annotations of text for speech synthesis applications.
So this is
This signals a Watson text-to-speech service to pronounce each.
Okay, this is the SSML markup language I was talking about. And you can tell Watson text-to-speech, okay, I want to speak each letter, or I want to speak the content as digits, or phone numbers, or dates. And so you can basically mark up a very simplistic piece of text and have the text-to-speech service intelligently speak it out. So this is going to interpret each of that word that I've wrapped the SSML around as letters, and then speak it out as a word. Okay.
Here's what this example sounds like.
Hello is spelled H-E-L-L-O.
So you can see how simple that was, but that was a very cool idea I had was, could I teach someone how to spell? Based on, you could maybe listen to a word and then spell it out. So the child could say hello, and TJBot can say, oh, hello is spelled H-E-L-L-O. So yes, again, it's a kid-oriented activity, but think about adults trying to learn another language or relearn after having an accident. Simple things like that can change a human experience quite a bit. So if you walk away saying, I can write code, I can prototype a cool idea, and maybe help someone out, that's a pretty cool experience being a developer. So if you've learned something today that you've learned how to code this weekend. Now you know that you can actually make an impact. So, all right. And then let's see, go back to GitHub. We can recognize in colors, objects. It can shine a light a certain color. Again, waving, translating. So anyone have an issue at lunchtime at work trying to figure out where you want to go for lunch? That's a real struggle in my office. We've got 8 developer advocates when we're all in the office going, I'm hungry, where do you want to go? And it's usually the same restaurant across the street, right? I love that restaurant. I won't name it, but yeah, let's pick another restaurant, please. All right. So what I did with the Watson conversation, let's see, was train Watson with, oh yeah, you should see this, Amy on the IBM media, the social media team, likes to Photoshop things, and apparently I'm a chef. I'm not really, but so you can see the Watson conversation service. I've trained find lunch as an intent, and then different cuisines, because we all want variety, right? And then the conversation tooling basically recognizes the intent, and then I have different options. I've trained Watson to say, okay, sandwich at cafe venue, or a roast beef sandwich at specialties. And then really very simple, I've told Watson to randomly pick one of these responses. It's not at all intelligent. It's just responding with a random response. And that's how I randomly pick what lunch I'm having. So if you have that problem, here's your solution. And I guess tomorrow is your first day to try it out. So there's also a tweet node that you can tweet either text or a photo. So I take a photo with the TJ bot and I tweet it out. And so, yeah, yet another bot on Twitter. You can also direct message your bot and have it speak out to you. So if you want to be creepy and have your bot say something to your other family member when you're not home. Yeah. All right. Enough for that. Shouldn't be encouraging this behavior. Measuring the CPU. So how hot are you, TJ bot? It'll speak out that. The weather. Speaking headlines. So it will pull an RSS feed from the New York Times AP Online RSS feed and read out the headlines to me and whatnot. So these are just, 29, 30 examples that you can do with the TJ bot and in Node-RED. You can also write Node.js code as well. Coming up at 2 o'clock, we'll have a hands-on lab. I believe it's going to be upstairs again. We'll dive into actually getting hands-on with the TJ bot. If you're interested, we have this TJ bot simulator that is all in the browser. All you do is go to Watson or to Bluemix, get your Watson credentials, put them in here. Don't copy them. All right, there you go. And so this one is analyzing the emotion of things. Let me turn this one off. I can analyze text. Well, shoot, it's already feeling joy. You've been an awesome audience today at SVE Code Camp. So I'll run this, and you can see the response that comes back from the tone analyzer service and which emotion. Oh, good, it's joy. I hope I don't offend you by showing joy. No. And so the TJ bot will turn its LED the color yellow based on I've got the emotions correlated with a color, and so I could also simply TJ bot shine blue, and it'll turn blue. So there's different code examples you can click and they'll populate into the code editor and run them, showing you the different Watson services that you can utilize. You can have it listen via the microphone on your laptop. It'll take a picture with your webcam, and it'll talk to you over your speaker. So if you're interested, definitely play around with that. There's a link, ibm.biz/tjbot, code challenge. And these will challenge you to use the 5 services and using that simulator. Again, you can take this code, put it on the Raspberry Pi, and run that as a node application. So they correlate pretty well together. Unfortunately, the simulator doesn't actually push code onto the Raspberry Pi yet. I'm working on that next. So hopefully that has inspired you. And let me wrap up with a couple on. Yeah, okay. So IBMTJBot.github.io is the site where you can find all the NPM libraries, all the recipes. There's many YouTube videos that you can watch that have been contributed by the community. For example, that conflict resolution, a weather report TJBot, recognizing classic monsters, many other ideas that you can also deploy onto your TJBot. Developer.ibm.com/code is where we have code journeys for more on Watson, on AI, APIs, blockchain, tons of IBM products. You can play around with that. And if you're interested in the Watson services and SDKs, we offer them in different languages. GitHub.com/Watson Developer Cloud. And that's my info. Thank you very much. And at 2 o'clock, stop by at the lab, and we'll continue this.